Okay, let's do another geometry problem. And this one is going to involve right triangles. Believe it or not, this is actually a problem which we are going to have to solve in not so long. It's one of the more difficult geometry problems we have to kind of understand in the course. So let's see what happens. So I've drawn a picture in the slide already here. There's one known angle here, and you have two horizontal lines. Those are exactly horizontal. You've got one vertical line, which is exactly vertical. I'm talking about horizontal here, horizontal here. You have a vertical here, and this angle here is at a 40-degree angle to the horizontal as shown. So the question is, what are all the other angles? Suppose we want to know all the other angles in this picture. What are they? So let's just kind of go through systematically. Well, there's two right angles already marked. This little square here means that this is a 90-degree angle. So that's already done for you. If that's a 90-degree angle, this one is also a 90-degree angle because those two are a straight angle. They have to add up to 180. And also this combined angle here is a right angle, and this is a right angle, and this is a right angle, because those are just a horizontal line and a vertical line intersecting with each other. Now, if we have a 40-degree angle shown down there, there's a number of other angles we could figure out. Let me actually do this a couple different ways maybe and show you there's always kind of more than one way to skin a cat in geometry problems. One method, using what I talked about in the geometry video, would be that if this is a 40-degree angle down there, that would mean this is also a 40-degree angle because that is a corresponding angle to the given one. And if that's a 40-degree angle, this is also a 40-degree angle. First of all, it's an alternate interior angle to the given angle, and also it's a vertical angle to the first one I mentioned. So doubly certain that that one is also a 40-degree angle. Now, switch colors. If that's a 40-degree angle, this one here has to be a 50-degree angle. Why? One argument is that this has to be complementary with the given angle because they're both part of a right triangle. And the two angles here and here in a right triangle have to add up to 90 degrees because all the angles in the triangle have to add up to 180, and 90 is already spoken for. Also, because I know that this is a right angle there, those two angles also have to add up to 90. So I know that that one's 50. Once you got that that one's 50, you can say that this one is also 50 because those are vertical angles. We know this one is 90 because that is a vertical angle to the other 90-degree angle given. And I think we've already knocked off every angle in the picture here. So when we actually use this problem for practical applications, the practical application, by the way, is going to be when something is like sliding down a ramp. Picture this inclined line here as being like a tilted tabletop, and you're sliding something down the ramp. We're going to need to know, what's the angle between the vertical direction and the ramp and things like that. So this kind of geometry problem will be useful later on.